Teleconference, which was held on March 25th, 2015. To back the conference up 30 seconds, press 7. To pause the conference, press 8. To resume, press 8 again. To fast forward the conference 30 seconds, press 9.
Welcome and thank you for standing by. At this time, all participants are in a listen-only mode until the question and answer session of the call. To ask a question during that time, please press star then 1. Today's conference is being recorded. If you have any objections, you may disconnect at this time. Now I'd like to turn over the meeting to David Stites of NASA. You may begin.
Thank you, and good afternoon, everybody, and thanks for joining us for today's call to discuss the agency's Asteroid Initiative and some recent developments with the Asteroid Redirect Mission and our recent mission concept review. In the room with me today is Robert Lightfoot, our Associate Administrator, along with Michele Gates, our Program Director for the Asteroid Redirect Mission, and Lindley Johnson, our Program Executive for NASA's Near-Earth Object Program. Also in the room is David Weaver, our Associate Administrator for Communications. We're going to open with some comments from Robert, and then we'll take questions from folks on the line. Because of time constraints, we'll need you to limit your questions to one for the first round. I'll let you know now if you have a question or plan a question, hit star 1 to be added to the queue. This call also will be available for playback starting about an hour from now at 800-839-2215. In addition, we're updating our website with more information, including some new graphics and animation. The website for the Asteroid Initiative is www.nasa.gov/Asteroid Initiative, all one word. And with that, I'll turn it over to Robert Lightfoot.
All right, thanks, Dave. Appreciate it. And thanks for everybody for joining us this afternoon. Yesterday, we completed the mission concept review for the Asteroid Redirect Mission, the robotic portion of that mission, the part where we're going to go get the asteroid and bring it back into cislunar space so that the astronauts can get to it using Orion and SLS, which is, frankly, a very important piece of our path of taking humans further into space and ultimately into the Mars vicinity and hopefully ultimately to Mars. So we went through the process. To give you an idea what a mission concept review is for us, it's a review. It's a standard review in our lexicon here at NASA that we have early on, and it's really the objectives of that meeting are to evaluate the feasibility of the proposed mission concept and its fulfillment toward the program needs and objectives. And what we do after that is we enter into what we call Phase A, which is our life cycle within the agency. And so what we check is it addressing critical NASA needs? Is the proposed concept feasible? And is the associated planning sufficiently mature to begin a Phase A so that the mission can likely be achieved? So that's kind of our overall objective that we have for all our projects we go through. So yesterday what we heard from the teams, we got an overview of where they were from programmatically, and including the assessment of the options. We talked about the flight systems, some of the heritage hardware of the flight systems, and some of the maturity levels of those flight systems as we move forward. We got a good brief on where we were with solar electric propulsion, as you know, a critical technology that we want to develop on our path to Mars. That will demonstrate. That's a capability we're thrilled to be able to demonstrate with this mission. Then we went with both options. Option A, which is the capture mechanism where we go grab one as it's coming toward us and capture it in free space, and then option B, where we actually take a boulder off of an existing asteroid and bring it back. We got an update on their progress since we've had the sort of several risk reduction activities going on there, and update on some actions we'd given them from the last review at the down select meeting where we if you remember, we traded the complexity and a little more expense from option B versus the option A capture activity. We then looked at some of the development and mission risk activities that were going on, the top-level risk assessment from that standpoint. We heard back from an investigation team. This is a team we kicked off after the last meeting where we said, hey, if we're going to go do this, we need a team to pull together to help us determine what do we want to look for, what type of science objectives can we get, what kind of planetary defense objectives can we get. I'll call it the other benefits of this mission related to what we can actually accomplish while we're doing it. And so we heard from that team as to how they're getting that approach put together. We had an overall view of the management approach, the cost and schedule that go with it. We got an update from the crew side of this particular activity in terms of the interfaces that the crew will have with the asteroid when we bring it back into cislunar space, and the types of things we'll do to the spacecraft that's going to get the asteroid to prepare it for humans for the astronauts to go out and interact with the asteroid when we get it back. Then we had an independent review team that we've had in place the whole time that's been following along with the program. They went through their response, and they went through everything that they had looked at and gave us a pretty frank and candid assessment of where they thought we were. And at the end, we had a discussion amongst the team. That was probably the largest part of the day, was the discussion amongst the team around did we meet the objectives of a mission concept review, and are we able to move into Phase A for this program. At the end of that review, it was unanimous. We're ready to move into Phase A. We're gonna do that. We approved the mission concept review and are allowing the team to move into Phase A. And I got to tell you, it was a very exciting review. A lot of great work had been done by the team. And when you think about what we're trying to do with this Asteroid Redirect Mission, I mean, it's bringing together the best of NASA's human exploration, science portfolio, technology portfolio, and really give us an opportunity to demonstrate the capabilities we're going to need for further future human missions, beyond low Earth orbit and then ultimately to Mars. It's going to allow us to do the work in the proving ground, the area around the moon, the cislunar space. We want to do that, where we can work on our solar electric propulsion. We can start using Orion and SLS, testing those systems out. We're going to be doing EVAs from Orion to interact here. The navigation, rendezvous, and docking activities we're going to be doing in this distant retrograde orbit are just, it's just fascinating what we're already learning as we go through this process. And then you get the other benefits of the planetary defense activity we'd like to demonstrate on this mission, the activities associated with interacting with another body in space, and then actually moving it and transiting it back to cislunar space. So it's pretty exciting, and it was very exciting to see how much the teams have done. Really proud of them, and so looking forward to the next phase as these guys go through this. And at the end of the day, since we talked about this, we selected the option we're gonna go to asteroid and take a boulder off of that. So that was the selection that we're going to go with. That's the team. I gave the team direction to pursue that mission concept as we proceed into Phase A, and let's get on with it so we can get this journey, this next key step in our journey to Mars, moving on. So that was what yesterday consisted of, and I'll be glad to take any questions.
Okay, thank you, Robert. And we'll get on with questions. Again, if you have any questions, please hit *1 and you'll be added to the queue. Our first question will come from Seth Bornstein of the Associated Press. Seth?
Okay, Robert, you buried the lead there. At the very end, told us which one it is. So tell us, what were the benefits? Why was option B, to take a boulder bit? What was the reason that was the choice over grabbing an entire asteroid, or an asteroid that's using an asteroid that's coming toward us? Can you go through the cost, the time? What were the cost and time differences in giving us the details on the cost and time for both options, and essentially what is the main reason you chose that one?
Sure, Seth. From my perspective as the chair of the meeting, and it's very similar to what I discussed with you guys last time, there was a significant amount of debate around extensibility, what's more extensible for us, systems that we can use as we continue this journey after this mission. ARM is an important part of the overall mission of us taking humans further into space. The difference at this time at the level of granularity we are is about $100 million. When we looked at it, but the systems that we bring into play, a lot of the systems in terms of the capture mechanism, in terms of the way we're going to interact with the asteroid, in terms of almost a soft landing, for lack of a better word, on the asteroid, and then pulling it up. The technology used to grab onto the asteroid, the microspine system that JPL has been developing for a while, are the kind of things we know we're going to need when we go to another planetary body. So that was really important from my end. The other piece was going to another asteroid allows us to actually survey that asteroid. We've got time to survey the asteroid we know from all, I think, and Lindley's here, he can jump on me if I get this wrong, but we know from the asteroids that we have seen and done precursor missions to, they have boulders on them, targets for us to actually pick. We're going to have a sensor system on this, sensor suite on this on the spacecraft that will allow us to actually look at the boulders and actually make an educated choice of which ones we're going to pull. The other piece is I've got 3 to 5, depending on how it ends up, I've got 3 to 5 opportunities to pull one of the boulders off of the existing larger asteroid that we're going to go to. So all that gave me a mission risk consideration. I felt like we'd have a better shot at bringing one back. The extensibility of the hardware, the larger planetary defense. There was 2 different planetary defense objectives. The capturing the one in option A was an ion beam pulsing type of planetary defense. This was more of a halo. We'll take the mass and we'll have time to station keep around the bigger asteroid and see if we can actually move it and measure that and have that measurable movement. So all that together made it worth it for me to take a chance on and with the dollars to build those systems, have the extensibility to that, but also have I felt a better shot from a risk perspective of actually getting there. We have it just to throw it out there, so I probably should have said up front, but we're looking at a December 2020 launch date for this spacecraft, and we have probably our leading candidate right now, asteroid that we have out there is 2008 EV5, which is one that we think we've got fairly well characterized. However, we're going to continue to look. Lindley Johnson's program, we've had a 70% increase in the amount of targets we've identified, whether they're amount of asteroids we've identified, whether they're applicable to this mission or not. And we'll continue to look, and we don't have to make a decision on what asteroid we're going to until roughly a year before the launch, so somewhere in 2019. Does that help, Seth?
Yeah. You said 2008 E as in everything, V as in Victory 5?
That's correct.
Okay, we'll take a question now from Jeff Faust of Space News. Jeff?
Yeah. Can you tell us basically what's the next step now? Now, as you've done the mission concept review and can move forward into Phase A, what's going to be going on basically for the next year or so? What should we be looking for if you're not going to make a decision on even a target until as late as 2019?
Well, so there's several things going on. In fact, the teams are glad to be moving because the timeline is going to be tight. So I would put the biggest issues we have coming up is we've got acquisition strategy meeting in July. This is where we'll decide how we're going to procure all these systems, and the teams have to go do that. This is fairly quick for us from that perspective, and that's mainly in the solar electric propulsion area to start with. We've got to get those pieces moving, and the strategy behind that are, how are we going to actually acquire that? Is it going to be in-house? Is it going to be procured? Those different pieces are going to be that's the biggest thing for us. That's the next big milestone coming up. In the meantime, we got an integrated requirements review that will help us refine the cost estimate and the schedule that goes into the budget preparation process that we go through every year. So that'll be the next big step coming in. To go into Phase B, they'll have to bring me a range of cost associated with that in our vernacular. So it's really a refinement phase. Is Phase A, and a lot of risk reduction activities that we'll get to go do with the funds that we already have.
Okay, next up, we'll take a question from Eric Berger of the Houston Chronicle. Eric?
Yeah, hi, guys. Thanks for doing this today, and ladies. So a quick question. How big approximately would the asteroid be? I'm sorry, we've got that. How big would the boulder be, and what would the time frame be for actually having astronauts and Orion visit it in cislunar space?
Well, I think that the size will depend on which one we pull. This particular option, we're confident we can get up to a 4-meter, depending on when we launch and depending on which one we pull off of the particular body, based on our identification, the process we're going to go through. What was the second part? Let's see. And the availability is right now we're looking at late 2025 to take the crew there.
And just to clarify Seth's question, you said it was $100 million. Was the option B $100 million more or $100 million less than option A?
$100 million more.
Okay.
I've asked the team to work, as we've said before, to a cap of $1.25 billion. and that's what they're going to be refining over the next plus the launch vehicle. That doesn't include the launch vehicle. $1.25 billion over the next over the Phase A process.
Okay. Our next question will come from Eric Hand of Science Magazine.
Hi, yeah, thanks for doing this. Slowly getting there on the timeline. Okay, so launch in 2020, crew encounter in 2025. When would the encounter with this leading candidate be 2008 EV5?
Yeah, it's roughly 2 years after we launch. And then we're going to be there for this particular time. We'll be there. We can be there anywhere from 215 to 400 days, depending on how long of a planetary. Most of that is the gravity tractor demonstration of can we actually move the bigger asteroid. So we would get there in 2022, spend roughly 215 to 400 days were the options we saw yesterday, and then we would start transiting back to cislunar space.
So up to 400 days at the asteroid?
Yep.
And quickly, if I can ask, what you highlighted the reasons for choosing option B, but can you explain some of the risks that you felt made option A the lesser candidate?
Well, I think just kind of the opposite of why I chose option B. The systems weren't quite as extensible to what we'd be doing on our path to Mars. The capabilities that we need to demonstrate, again, not just for this mission, but for all the missions that we want to do with humans in the future for there. And then actually the target identification, while we're still looking for targets, they're pretty hard to characterize, and the uncertainty around those gave us a little pause. I think we'll find one. I think we would have found one there, and I think that the team that was working option A, frankly, they did an outstanding job with what they proposed. But that was for me, that was the risk of having a target that I was comfortable with, that we would be able to get there. It's a one-shot deal. We get out there. It is what it is when we get there, versus having some options when I get to the larger asteroid, of which boulder I pick, and then the extensibility of those systems toward what we want to do as we move humans deeper into space.
Okay, we'll now take a question from Mark Crow of Aviation Week and Space Technology. Mark?
Yes, thanks. Could you review the sort of reconnaissance you've already done on the target, and also provide an estimate on the date that it would show up in cislunar space at the distant retrograde orbit?
Yeah, the date we're going to bring it back is what I was talking about a minute ago, 2025. That's when we have it show up, late 2025. I'm going to let Lindley talk about the reconnaissance piece. Lindley Johnson, who's our NEO program manager.
Yeah, hi. Well, for the valid candidates that we have, we've got 3 of them that are asteroids that spacecraft have either been to or will be going to here in the next few years. For 2008 EV5, which we've identified as the candidate that we're doing our detailed design against. 2008 EV5 has not been visited by a spacecraft, and there are no plans until we get there with the armed spacecraft, if that's what we choose as the target for the mission when that time comes. But it has been extensively observed for determining its orbit. Its orbit is very well known. It has been observed by IR telescopes to determine the type of asteroid it is. It is a carbonaceous type C asteroid, which is of particular interest to the scientists because of the volatiles and elements that we know to be in those type of asteroids. And it has also been observed by radar and imaged by radar. So we have a very good idea of its size, shape, its spin dynamics, and the potential existence for the right-sized boulders on the surface.
Okay, next up we'll hear from Marcia Smith of SpacePolicyOnline.com. Marcia?
Thank you very much. Could you go through the costs again? I know that you separate the cost for ARM into money for things that you would do anyway, even if there was no ARM, and then money that is specifically for ARM. And so of the $1.25 billion, how much of that is money for projects that you would pursue even if ARM wasn't on your agenda, like solar electric propulsion, and how much of that is this non-leveraged funding?
So, Marcia, I think I don't have the exact numbers in front of me. We're going through that as part of the budget process. I'm trying to think if I can even give you a good estimate.
Maybe you could phrase it in terms of going forward for the next, say, 5 fiscal years. Is there going to be an increase of $1.25 billion to the NASA budget to pay for this, or is it money that you already have in your run-out?
Yeah, I think there'll be some increase that'll be specific to the mission, but it is definitely not all new money. It is because we will take advantage of the solar electric propulsion, which we estimated roughly $300 million, which we were already going to do and is already in the run-out for space technology. There's some capture techniques and mechanisms that were already in parts of the human exploration budget related to some tools and techniques we were doing that are already going to be covered in there as well. The exact breakout, though, I don't have in front of me. So that's part of the budget cycle that we're going through with Phase A.
So will we see that in your 17 budget submission?
I hope so.
Thank you.
That's my plan.
Okay, our next question will come from Alan Boyle of NBC News. Alan?
Thank you. I was trying to get straight the human spaceflight component of this mission now that you've talked about 2025. How long would the human crew spend at the asteroid? What do they hope to find? And if they're being launched in 2025, what sort of effect does that have on the schedule for other Orion SLS launches, say in 2021 going forward?
That's a great question. I think for us, let me answer your first question first. That once the asteroid is there, we're looking at a 24 to 25 day mission. The teams have been working on it pretty hard. As I said yesterday, we got a great briefing from the crewed portion of this particular mission in terms of some of the mission kits they would need, some of the things they would need to go do this, and their interaction would be we'll attach the spacecraft that's going out to get the asteroid will have a docking mechanism on it so that the Orion can come right up to it and dock. The crew will then do an EVA. Both crew. It's a two-member crew, a two-person crew. They'll both go out and hopefully, with option B, the other thing that I didn't emphasize is we have a way to actually analyze the asteroid as we're coming back, as we're bringing it back to see if there's a particular area that we would want to harvest first for interest reasons. So they'll do that. As far as how this impacts the SLS Orion program is continuing just like it would. They'll go to the DRO, probably go there from a practice perspective if the asteroid's not there yet to make sure the techniques and that we have in place are what we think they are before we actually have to interact with the spacecraft. But we will continue on that cadence, just as if the same cadence we were already planning. And when the asteroid is there, that'll be when it gets there. That'll be our next chance to take the crew there from that perspective. So it doesn't really affect the planning of the EM1, EM2, EM3. However, knowing it's going to be there actually helps them plan better for EM1, EM2, and EM3. Some of the techniques they might want to do before we get there to really do some risk reduction from an operational perspective.
Okay, our next question will be from Robert Perlman of Collect Space.
Hi, thanks. It's been mentioned a couple of times about just now about the analyzing the asteroid on the way back, but this isn't primarily if I'm not mistaken, a science mission. How much will science drive selection of the actual boulder to be brought back versus capability demonstration for the human side and exploration side?
Yeah, that's a great question. I mentioned the investigation team that we got the briefing from yesterday. Part of that investigation team is actually putting together, now that we know what we're going to do and we're going to demonstrate these capabilities, let's pull them in almost as because we're going to have multiple benefits here from that perspective of what would be some of the key characteristics we want to use use as a selection criteria. We can start doing that now. Now that we know what we're doing, it makes in terms of the option that we've chosen. It lets us make some judgments, bring in the science community, bring in the the planetary defense folks and have them on our team as we make these kind of choices. But the capabilities we're demonstrating, I mean, again, while they're independent of that particular benefit. However, the capabilities give us the benefit of allowing us to actually assess the sites that we're going to pick from. It allows us to actually do the look at them, and we got a couple of years from the time that we've picked the boulder up to the time we get back to cislunar space that perhaps we can actually then infuse what we're going to ask the crew to go do. Again, we're trying to prove the techniques with the crew to interact with this other body, but if they're going to do that, we have a great opportunity here to interact in a way that gives us the most scientific value and the best value from a planetary defense perspective.
Okay, we'll now take a question from Marcus Wu of Wired Magazine. Marcus?
Hi, thanks for taking my call. I guess I had a follow-up question on that last one. Why is it that option B would provide more opportunity to analyze the asteroid, I guess from a scientific point of view? And also, if science isn't really the priority in this mission, are there certain things that are priority? For example, is it the solar propulsion system, grabbing the boulder, or what?
Yeah, I think so. The priority from our perspective is really kind of, we call it a capability demonstration mission. I mean, we are really trying to demonstrate capabilities that we think we're going to need in taking humans further into space and ultimately to Mars. I mean, that's what we're looking at. However, we recognize there's definitely a scientific benefit here with what we're doing, and so that's why we're going to pull a team together to help us with that. The reason that option B, again, in my opinion, as the chair of the meeting, was a better option is because we know the larger asteroids have, we know from what we know of asteroids we've been to, they have boulders on the surface, right? And so when I get there, I have an opportunity to, with the sensor suite we're going to put on here, to actually assess and check those boulders out and decide, I'm going to have multiple targets when I get there is what it boils down to. And at that point, we can then assess which one we want to go after. I then have 3 to 5 tries at getting it, or I can actually move to a different one. Coming back, I have a sensor suite that allows me to start assessing what's actually in that particular boulder that we've pulled off of the surface of the larger asteroid. So that was the better value, in my opinion, for what we're trying to do.
Next, we'll hear from Mike Wall of Space.com.
Thanks, guys. This is just a quick question about actually, the actual planetary defense aspect of this. Could you go into a little more detail about what you would hope to accomplish on that front with the 400 days, or however long you end up spending at that larger asteroid before you start heading back with the plucked off boulder? I mean, what sort of activities are you going to be doing during that time, and what do you hope to achieve?
So we've got the plan is once we take the boulder off the surface of the larger asteroid, right, we'll go into what's called a halo orbit, which means we go around the larger asteroid that we've now left, and with the mass, now we have the mass of the boulder we've taken off the surface of the larger asteroid. We'll go around that. We'll fly around the bigger asteroid, and what we want to do is demonstrate that I guess in space, everything has a mass, right? And everything has gravity, and when you can do those together, you can actually, the mass of the spacecraft with the boulder on it will actually influence the gravity and the movement of the bigger asteroid. And it takes a while because we're small. We're not. This isn't a big thing. It's not precise as much as it is. We want to prove that we can actually influence that. And we're not talking about a large deflection here. We're talking about a pretty small deflection. But we think we can measure it with our assets that we have here on the ground, the radars and the telescopes that we have, right? And I think that's what we're trying to demonstrate. And it takes a while. That the reason we're you're talking about a very large mass we're trying to influence by a very small mass. That's why we're saying 215 to 400 days. And once we understand we've actually influenced the larger asteroid, then that gives us an idea of, okay, how much more do we want to do that, or do we want to start heading back to cislunar space? That's what we're trying to demonstrate from that perspective.
Okay, we have time for one more question before we wrap. just a reminder that the call will be available for replay starting an hour from now at 800-839-2215. And for our final question, we'll hear from Irene Klotz of Reuters. Irene?
Thanks very much. I'm not sure who'd be the best person to answer this, but I was wondering what sort of commercial participation you anticipate the project might have, both for companies that would be interested in the asteroid and also for any companies that are interested in doing space tugs, things like that. Thanks.
Yeah, I think that's part of our, Irene, there's several places here. One of the other pieces of the data that was interesting, and again, I when you asked me what the difference between A and B was, it wasn't a big swinger, but when we actually put a request for information out associated with the option B, we had a lot of interest in from I would say from traditional folks that we work with and non-traditional folks. There seemed to be a great deal of interest, not only domestically but also internationally in that particular option. So during Phase A, we'll peel back those opportunities, and they'll factor into our acquisition strategy. There's been a lot of interest in if you look at just the solar electric propulsion, just the spacecraft bus. There's a lot of interest out there in terms of, as we said before, tremendous applicability to different industries, whether it's geocom satellites or whether just space tugs, as you said. We seem to have a lot of interest in that. And that's all going to factor into our acquisition strategy we do in pre-Phase A. So we felt like option B actually did offer us more of an opportunity to engage more folks from that area. But the team brings that back to me in an integrated fashion when we come to do our acquisition strategy meeting in July.
Okay, that's all the time we have for today's call. Thank you, everybody, for joining us. For more information about today's news and our asteroid initiative and our journey to Mars, please visit us on the web at www.nasa.gov/asteroidinitiative. Thanks very much for joining us today. Thank you, Robert.
Thanks, Dave.
This concludes today's conference. Please disconnect at this time.
Thank you for calling the Digital Replay Service.